Hi, my name's Grant Thomas and welcome to the UK's first EVSE Build Day here in my garage in Emsworth on the south coast. Today is Sunday the 20th of October 2013 and on this video we're going to show you how to build your very own portable electric car charging station. I'll come on to how that will be useful, but let me introduce two guys to the left of me here. First of all is Kevin Sharp. Hi Kevin.
Hello. Thanks
for coming. Kevin's the founder and patron of the charity Zero Carbon World that has installed electric vehicle charging points throughout the UK. He also took his Tesla Roadster right the way from Land's End to John O'Groats. Co-piloting that on that trip was David. Hi David.
Morning.
Thanks for coming. David's got a Vauxhall Ampera himself. Myself, I drive a Nissan LEAF for 2012. I've just done about 16,500 miles in a year's worth of ownership. So let's just recap what we're going to cover here today. We're going to do a build of a charging station. We think the skill level's around that of a competent DIYer, but some health and safety messages ahead of that. If you are going to attempt this, do make sure you get it checked by an electrician before plugging it anywhere. And we're going to go through exactly stage by stage what you'll need to achieve this build. Now, why is it useful? If you're an electric car driver, you've got a Nissan LEAF or a Vauxhall Ampera or maybe the new BMW i3, you may be out and about and you need to plug it into a charge. And an example would be plugging it into a 32 amp Commando or a 16 amp Commando socket like this, and it'll allow you to charge your car at a much quicker rate than the supplied cable that comes in with the car itself. So we're going to take you step by step how to build this and show you exactly how you can then utilise this when you're out and about on the road. So Kevin, you've kindly brought along all the parts we need today to assemble the charging station. Could you take us through the main components that we need for a charging station?
Yeah, absolutely. So what we've gathered here is some examples of the parts that you will need in order to put this together. All of these are based on commercially available parts that you can get off the shelf. And to begin with, we've selected an aluminium case for this. This is a fully IP67 waterproof case. People obviously can choose all different materials for these. You can use plastic, etc. But we've chosen aluminium because it's very robust. This particular version has a window on it, and this is very useful because it allows you to get to the components and reset the circuit breakers, etc. Should you need to, and we'll explain later why that may be beneficial. Inside this is, if we have a look, so this is has a standard DIN mounting rail which uses commercially available components, exactly the sort of thing that you might have in your distribution board at home. And these are very ruggedized boxes which provide basically input for the power from the wall and an output for the switch power to the car. And the sort of connectors that we're interested in are for the LEAFs and the Ampera, what we call the Type 1 or the J1772 connectors. This is a universal standard, and that's one of the options. Second option would be a Type 2, so the sort of thing you'd get on a Tesla Model S or a Zoe. The design fully supports both of these. And there is indeed a third option. Should we have a larger box, we could actually use a Type 2 socket, which would be very useful if you were building a charging station that you wanted to put onto the wall. But we won't be covering that today because we're really focused on the portable device. So here we have a typical RCBO. This is a device which is really designed to provide protection or safety for the design. So this provides a function as a fuse, but also provides an RCD function, which is basically a detector for should anybody come into contact with a live wire within the design and provide a current route to ground. This will actually trip the power. So it's a critical safety device.
So you've just taken us through, Kevin, all of the components inside the portable charging station we're building today. Can you actually talk us through the two different types of cables and connectors you've got?
Yeah, absolutely. So if you have a look here, what we've effectively got, this is the Type 1 or J1772 connector, used on a lot of EVs that are being deployed today. And if you were to look, you'd see that it has only 4 wires on it.
All right.
And the wires are effectively a live, a neutral and an earth, which we're all familiar from our house wiring. and then there's one other which is the pilot signal.
Right.
And the pilot signal is responsible for all of the protocol and all of the communications between the car and the EVSE. And then it's also interesting to note that the second type connector, the Type 2, also has 4 wires. So it's important to understand that the protocol between Type 1 cars and Type 2 cars is exactly the same.
It's just a different connector on the end of it. So this is Mk, what some people know it by?
Absolutely,
okay.
yeah. We try to call it Type 2 in Europe, but Mk are the original developer of the connector. So
I'm familiar with that one from the Leaf, because that's the one I've been using on the zero carbon foil cable. In effect, you've got one of those at one end that goes in the public charging station when you're out and about. That goes in the front of the Leaf or the Ampera. This is the first time I've seen this though. This is the new one, the new cable? Or?
Yes, this is the Type 2 for the car connector, so you'll find this on the Zoe, the Model S and the i3.
Okay.
It's a very versatile connector in that it supports not just single phase power, which the Type 1 does,
right,
but also does 3-phase power.
So what can that handle up to then? If
this will actually support up to 43 kilowatts.
Oh, right.
And so it's a significant improvement over the Type 1 and is very versatile in Europe.
Okay, so these they look very similar, but it's the same make. I see their ITT, I think it's a Mark II or a Type 2 connector or something like that. Can you talk us through why that brand, why that choice?
Yes, ITT are a connector that we've used over the last couple of years.
Right.
We've sold hundreds of them. And in fact, the large majority of people with Type 1 to Type 2 cables today in the UK are using the ITT connector.
Right.
It's a very robust and reliable connector. And one that we feel very confident to deploy because of its reliability.
And when that's plugged in the front of the car, it's completely watertight. Nothing can ingress into there. It's completely safe.
Absolutely. That's a really important point to get across. Of course, is that we're really focused on safety with this build. And everything that we've done, the unit itself will be IP67.
So completely watertight.
Completely water, that's
if
right.
If ever a fault, it's earth, so the whole thing tricks out. So
Indeed, yeah. And the cars are actually surprisingly typically around IP44, but that's still a splash-proof standard. So fine for the UK weather.
Okay, great. Okay, thank you Kevin for taking us through the different parts then. Let's turn our attention now to what we need in terms of building this. David, could you take us through what tools someone would need to attempt this build?
Sure. So really all you need are the sort of tools that you might have in the garage or around the house. A medium-sized Phillips screwdriver, a small flat screwdriver like this one, a set of wire strippers, and then a crimp tool which you can get from any DIY shop to crimp the ferrules onto the end of the individual wire strands in the cable, and that's it.
So we're now going to move on to the build, and we're going to start with the DIN components, the 3 main components. And the easiest way that I find to do this is to mount the 3 components on an external DIN rail, and we have one here. And I just mount the 3 components on that, and that allows you to wire it without all of the restrictions of the working inside the unit. So it's a very simple thing to do. One critical thing that we'll mention at this point is to be very careful about the RCBO and whether it's polarized. What I mean by that is that some RCBOs require power to come in one direction and out in another. This is an example of one that is polarized. Others don't care, but it will tell you, if you look carefully, it actually tells you on this unit itself. But do test that and make sure you're aware of which way round it should be. So now on to the build. So to begin with, we're going to put the components on the DIN rail, and the first one, we'll start with the RCBO, and that is then, in this example, will be followed by the contactor, and then finally by the EPC. What you want to think about a little bit is about how you're going to lay the modules out within the unit to make your wiring easier. But you also want to think a little bit about power dissipation of the, particularly of the contactor. So when you're selecting a contactor, you want to think a bit about its power dissipation and how much it's going to dissipate as heat, because that's the primary source of heat within the unit. We've selected one here that has low dissipation so that heat will not be an issue for us. Having assembled them on the DIN rail, we can now begin to wire up the components following the block diagram that we showed you earlier, which gives a basic overview of the wiring mechanism. We're assuming that, of course, that people have a basic understanding of wiring here and will follow good practice. As with everything else, it's critical to choose the correct cable for wiring the unit, and again that comes down to the expertise of the person assembling this. Here we're typically using 6mm squared cable, and we'll use that throughout for all of the power connections. That will allow us to have a sustained 32 amp load, which is the design limit of this version of the EVSE. So the first thing to do is to strip the relevant cables, and to use obviously the strippers for doing that. A handy tip for working out how long to make the relevant cables is simply to insert them into the device you wish to wire, and then you can just measure very simply how much you wish to strip off from the cable end. It's a very simple, easy process. So they're the ones to use. So the next step is to, having prepared the cables, is actually to put them into the ferrule that we're going to use to cramp them. And it's a little fiddly to get these in, but you know, crimping is the preferred way to do this. Under no circumstances should you be soldering these types of connections. So we'll do that. So having inserted the wires into the crimp, we now just go ahead and crimp them, and it's and then you end up with a fully crimped connection, which you know, is extremely robust. So fundamentally, that's what you do for all of the connections that you need to undertake to wire up the units here on this DIN rail. Okay. And we'll just put that one in there for now, just to, won't do it tight. So there's the first connection. So now we move on to the second one. So we have the first two connections made. So again, important to pull these, make sure that they're going to be nice and robust.
And when you're determining the length of this cable, Kevin, I mean, where's that got to go from and to, just so people can make that calculation?
Basically, it's going to go from there into one of the pins on the contactor. I think it was that one. Down to there. So basically, we're bridging between there and there, as shown on the block diagram.
Okay.
And obviously, though, what you do want to be wary of is that once those units are in the box itself,
yeah.
There is a clearance issue.
Okay.
So you do have to be conscious of how much space you're going to need there.
Okay. So this is the live side of the RCBO to
That's
the
right.
what port on the contactor?
So we're putting it onto.
Or what input?
It doesn't actually matter which. I mean, we've called it live one on the
Okay.
block diagram. The contactors are not normally. I mean, they're clear and obvious. There's always a diagram on them.
Okay.
On the top there, which shows which pins are switched on the connector.
Yeah.
But normally it's on the contactor.
Mm-hmm.
Normally you can assume that the flow is through the contactor. So this is a 2-pole. So there are 2 switches within it,
Mm-hmm.
and fundamentally this pin and this pin, that's one circuit, and this pin is the second circuit.
So you've gone into the one beneath number 4.
Absolutely.
Okay.
So this will become our live output when
Yep.
we're ready.
And the little red control cable?
Okay, now this is another live feed. This is the live feed that we're going to take to the EPC
Okay.
to this. So this provides live for this unit.
And much thinner because it is just the power to power that EVSE.
Exactly that,
Okay.
and it's there's no point in overdoing these cables because they just get extremely difficult to manage within the unit itself.
Okay.
And I just do these finger tight while we're working on it. And then basically we're going to sweep the power feed for the EPC around the unit,
Mm-hmm.
and it will come in, and there's basically the live feed on the bottom there. It's marked down that one. So that's where we're going to put in another one.
I'll just turn that round so we can show it to the camera. So it's the L live connection on the top of the...
Absolutely.
Okay, yeah.
So again, we want to put a small ferrule on that one.
And the reason why we use these ferrule crimps on the end, this just stops any stray cables going into a different, or any risk?
Yes, I mean it's what you'll find in they're not absolutely necessary in this, particularly when you're doing single connections, because these are designed for single connections. That's not a problem. But when you're using multiple connections, it's a good idea to crimp them.
Okay.
It's just a standard wiring practice. And they come in various different sizes, so that's one of the things that you have to be aware of.
And these particular crimps you got from, so just show the camera, one of these particular bags?
Yes, these are a German make. I mean, they're widely available and used within industries.
Okay.
There we go.
Okay.
So there we have basically the first feed done. So this is actually the live. So what we have effectively live from the RCBO into the contactor, and also supplying live to the EPC. So now we go on and do something very similar with the neutral line. Okay, so we're making good progress on the wiring of this. We're getting pretty close now to the final piece of wiring for the modules themselves. And as you can see, we've been crimping all of the high current connections are crimped using to ensure that we have a high quality connection there. So here we are with the majority of the wiring now done. Again, we're still on the external DIN rail just for ease, but you can see it's actually very simple, and we're just following the guidelines of the block diagram. At its simplest, what we're doing, we have power through coming in here through the RCBO and then out to the circuit. The primary place it goes is to the contactor, so you can see heavy duty high current feeds to the contactor, and then we take live and neutral off to the EPC. That provides power to the EPC, and then we also have a switched, as a live comes into here to one side of the coil of the contactor, so we have a switched path which basically turns on the contactor under the control of the EPC. So that fundamentally is the wiring of the module before we place it in the aluminium case. Of course, for all these screws, you can look at the relevant data for the part, and certainly in a production environment you would be torquing these to ensure that they're not over tight. However, you can use just good DIY practice. Don't overdo them, of course, but they must be tight. You know, obviously, if you can pull it out, then it's not tight enough. So that fundamentally is the wiring of the module before we place it in the aluminium case. So the next stage is to wire up the earthing, and what we're actually doing is to ensure that this design is as safe as possible. We have an earth block that also has a direct electrical connection to the DIN rail. So when this is fitted, there's a direct connection between the DIN rail and the earth connections within the unit, and obviously the DIN rail is screwed into the box. So there's an earth path there, but that we don't rely on that as being our only earth by any means. The other things that we do are we put in earth straps directly from the box itself. So we're going to again crimp on a ring, and then that will be screwed into this box, and we will do exactly the same thing on the lid on here. So what we've been doing here is we're looking at the earthing, and specifically what we've done is put in a bonding wire. So this basically ensures that there's an electrical connection between both parts of the casing. So that's important, so that, you know, should anybody be operating this with the lid off, we've got full earthing anyway. I've also temporarily inserted the earthing block, so we're going to take another bond from the case into this, and this will be the main input earth that comes in from the wall. So we're working on that at the moment. Yep. Good.
So the two cables you've got earthed at the top of the earth clip there, Kevin?
Yeah, so basically for this one on the block,
Yep.
yeah. So we've got the main earth coming in from the power supply,
Right.
That comes in and is crimped with one which we're using to bond to the case.
Okay.
And then we're using that into this block. So
Yep.
that's, if you like, our main feed in. So effectively we've got two connections to the earth connections to the box. There's
Yep.
one, this physical wire,
Yep.
and then obviously through the block through to
Yeah.
the thing. So, you know, there's double bonding there.
Do they need to be 6mm, those cables, or can they
No,
just be
no,
the earth?
they don't. I'm simply again reusing what we have
Okay.
available. You know, trying to be sustainable as best we can with this. So you'll find lots of cable. I mean, all the cabling here has come from our production. So we try and just, you know, reuse what we can.
Yeah.
And then what we've got on the other side, again, crimp, double crimp. We've got the
Oh, so that's going
earth
from-
coming in from the connector, so there's effectively a very strong connection, you know, direct bonding.
That's very neat.
Well, we'll see whether it goes together. Usually they look wonderful and don't fit, so that's what it. And then I've got another. This is the final earth connection, which goes to the EPC. So this is a main EPC earth. And then basically I'm ready now. So we have live and neutral coming in. It will come in from the wall, live and neutral that goes out to things. So effectively there's a contactor between those two.
Okay.
So that's the current path. That's the whole high current path of the unit.
Yeah.
Then we got control pilot, and that will just simply go to the EPC and the ground for the EPC. So you know, once you have the wiring of the module itself, beyond that the wiring in the unit is actually very simple. So now we need to actually insert these into the unit. Obviously it's going to be fairly tight because of the wiring we were wiring before, but literally you just place these in and they clip down. So, you know, should clip in like that. And they're all, you know, very robust in there, very solid. You can see all the wiring. Just make sure it's, yeah, so there's a pretty good job. Now one trick to bear in mind just for this particular thing is that there's a lip on the side of this, which means we do need a gap between these modules and this earth block. But we'll check the exact dimension position of all these connectors with when we've got the top on. But at the moment we'll just focus on actually wiring it next. So next, yeah, just wiring up these various connectors and then we're done. So there we are. So there's the unit, basically ready for now for the mains connector. So we'll wire that next, then we can do some basic testing before we actually apply power to it. But as you can see, it's still very, you know, very simple. We've tried to keep it the layout sort of clean and fairly obvious. Crimped. What we'll do is we'll go over all the connections in a minute, make sure they're tight. And then usually I check them again. You want to check them probably once a month, because of course this thing, particularly if it's in your car, is rattling around. So it's a good thing to make sure these things are tight. But you know, hopefully you can see it's a very simple thing. You know, and as I said before, it doesn't really matter what's on the end of this, whether it's type 1, type 2. Indeed, the contactor could be 3-phase. So you know, fundamentally this could scale from right the way up to 22 kilowatts, etc.
If you want to just describe what you're doing.
We've now got the unit fully assembled, and Richard's put the commando connector on the end for us. So we now basically have the whole unit, and so we're just going to run some basic continuity tests just to ensure that we've done a visual inspection, but we'll just make sure that we've got basic continuity. So we've got a multimeter. We're just going to do some beep testing just for continuity, and we just make sure initially that we've got the earths, and there should be no connection, obviously live and neutral. So we've clearly got that wired that way. And we'll check, and then we're just looking for same So the thing on live, not neutral. Good. Okay. Well, we've basically got the unit wired, so that's encouraging. Yeah. And we just do some basic tests now to ensure that we have no obvious shorts and that what we're expecting to be connected is. So got a line connection there. Good. Okay. So what we would normally do, having done some basic tests like this, is that usually this would go and have insulation tests as a minimum, and what I'd recommend is that you get your friendly electrician to look over the unit before you actually go any further. You need to bear in mind we're dealing with electricity and 32 amps, so 7 kilowatts, and it's just best to be safe. So what we will do is that we can get these will can go to the workshop and be tested there, just to ensure that they're safely checked. So I think we're actually ready then to power this one up.
Let's talk about it.
Tell me what you've been doing.
Okay, so while Kevin has been building an EVSE in the workshop, I've also been working on one behind the scenes, and so here's the moment of truth. We're going to test it with a car. So first thing to say is we've got it plugged into a 16 amp extension lead here, so through a Commando plug that goes into the EVSE box, and then over there on the ground we have the car end of the lead. So the first thing to do is open it up and switch it on, and you can see now that the control unit is going through its self-test. So it flashes various different colours on the LED, reaches this stage where it's now flashing blue constantly, and that means that it's waiting for a car. So with that in mind, we now have the car in, so the Type 1 plug over here. This is the connection into the car, so car's socket's already open and waiting, so we plug that in, and you'll see now the LED on the control box has gone green. That means it's negotiating with the car, ready to charge. The car beeps to say that it started charging, and the green LED on the dashboard of the Ampera is now on, saying it's charging, and everything appears to be working. Successful build, I think.
Great, okay, so we've completed two are working. David's Ampera is on charge and my Tesla's on charge, and we're getting close. Grant's just almost finishing off, so when he's finished we'll just review what he's done and then test it, and that's job done. So basically we've completed 3 today, which is good progress. Like all these things, it takes a while to get into them. So if you want to do this for yourself, and you have obviously, as you can see, it's going to take an afternoon to do. The hard to get pieces, which are really the cables themselves and the EPC module, those are the 2 bits which you may, well, they're available, but you may struggle to get them. Both of those are going to be available from the Zero Carbon World shop. Also, we're planning to put together a kit which will probably include the contactor and the RCBO. Those are the things that, just to make this easy for you. We will cases are readily available. You know, you can do it in aluminium, plastic, whatever you like. Obviously, you know, we've made a portable device today, but exactly the same technology would be used in a fixed one, if that's what you want. So I encourage everybody, you know, I hope what we're trying to do here is to show how simple charging technology really is. As you can see, 3 pieces really, which are available off the shelf, will allow you to do this. And just really emphasise again the safety aspects of this. Whatever you do, if you don't feel really confident with this, then please, you know, get somebody who's capable of doing this for you, and that would be, you know, a fantastic way of you know, achieving what you want. So I've certainly had a great day, and I'm really thanks to everybody here for supporting this, and we're going to go away and test Grant's version now. So
Which I'll be done about Tuesday, seeing as I've
yeah.
got one part on the cables now.
Well, someone over the next week will be testing Grant's.
Someone's asked on Twitter, actually, can we show the case? Can we show the finished case? So,
yeah, absolutely.
We'll make sure we do a zoom in on the camera to the case. All hooked up and working.